Hello everyone, and welcome to this latest webinar from IHS Markit titled 20 Minutes of Energy Storage Isn't Enough for the Grid Today. Nearly every vital network we rely on uses storage to address mismatches between supply and demand, but the electric power sector largely lacks this capability. So today our panel will explore the critical role of storage in this complex puzzle and how recent advances in energy storage can transform the entire electric power system. Our webinar is co-presented by IHS Markit and our partner AES Energy Storage. My name is Alan Tatara, Event Manager for the IHS Markit Technology Group webinar team, and I want to thank everyone for joining us. So before we get started, I want to highlight some features that are available for you on the webinar and also how you can participate and make the most of your experience with us today. So the webinar console that you're looking at is completely customizable. So you can enlarge the view of your slide area by either clicking on the Maximize icon on the top right-hand corner or by dragging down the bottom right corner of that slide area. And you can open, close, move, or resize any of the windows that you have open on your screen and arrange the console to suit your preference. Now, at the bottom of your console are a number of application widgets which contain additional features available for you. Make sure you check these out during the webinar. A couple buttons I want to mention. One is the Resource List widget, and this is the green button that has a document icon on it. And this is where you're going to find additional material about today's topic, including the downloadable slide deck from today's session, as well as other valuable resources from our sponsor, and also a special white paper authored by our own analyst, Sam Wilkinson. And all these materials can be accessed and downloaded right from your console, so please take advantage of these during the webinar. And we do want to make this an interactive session, so we've included a Twitter widget at the bottom of your screen, and this means you'll be able to tweet directly from the console. Today we are using the hashtag Energy Storage. Now we're also going to have a live Q&A session directly after the presentation, so we ask you to submit your questions or comments at any time by using the Q&A box that's on the left side of your screen. And of course, if you have any technical questions at all throughout the webinar, just make sure you click on that question mark icon and you will receive the help you need. So now let me introduce our panel. First, leading our discussion is Sam Wilkinson. Sam is Senior Research Director in the Solar and Energy Storage segment at IHS Markit. And rounding out our panel, we have John Zarancic. John is the President of AES Energy Storage. So welcome to both Sam and John. It's a pleasure to have you with us today. So now let's get started with our presentation. So Sam, I will turn it over to you.
Thanks very much, Alan. Appreciate the introduction. Good morning, everyone. Good afternoon, good evening, wherever you are. I'm really pleased to have so many people online from all around the world. We've got some really exciting content to share with you today. I hope you enjoy the session. I hope you find it informative. And I'm really pleased to be presenting alongside AES as well. So with that, we'll get started. Now, the electricity sector is changing, and it is changing incredibly quickly. And this is a change that is characterized by a transition towards distributed power generation. Not so long ago, really the entire electric system consisted of large, centralized, conventional power stations with electricity flowing in one direction through transmission lines and distribution networks to end users. And if we take Europe as a specific example, if we look in 2020, 20% of our power generation will come from wind and solar in terms of capacity. And also a meaningful proportion of that power will be actually sited behind customers' power meters. And this is one of the things that is at the very center of the transformation that we're talking about. It's also important to think that demand is changing and increasing. And what I mean by that is we're electrifying more areas, and we are seeing increasing demand for electricity from the automotive sector as more and more vehicles get electrified. And these are other things that are really adding to the major challenges that the electricity sector is facing. Now, we feel that those challenges are incredibly important, and in particular the way in which they are addressed. And this is what led to the white paper, Reaching Peak Performance. And this will be available for download for you all via the webinar console today. And this paper looks at other networks that are central to our lives today to see how they're coping with similar challenges and to see what the electricity sector can learn. It was a lot of fun to work on this paper, and it uncovered some pretty interesting findings. And my plan for the next 10 to 15 minutes or so before I hand over to John is just to share some of the highlights of this with you. Now, bear in mind that the paper represents the best part of a couple of months of work, so there will be things in the paper that we won't be able to show you today on the webinar, but please do feel free to get in touch with any questions or things that you'd like to discuss in the paper once you've read it in full. So networks are vital to life today, and they are present in nearly everything that we do. And at the same time, connectivity is also increasingly important, and not just in digital terms, but also in a physical sense as well. So people talk about the world being smaller, but I think in reality what we mean is that just everyone and everything is just much, much better connected. And it's not difficult to create an almost endless list of networks. And we looked at more than the 5 that are displayed here today in our research. But these are the 5 that we settled on that we felt were really important and really close to everyday life. And I'd be prepared to bet every single person listening to this webinar that they've probably already interacted with nearly every single one of these networks before even joining the webinar today, even those that are joining this early in the morning. Now, each network really faces the same challenge, and that challenge lies in balancing supply and demand. I tried to summarize that with this chart, which shows how demand for each network varies throughout a cycle. Now, in the case of the travel network, the electricity network, and the data network, that cycle is 1 day. However, for the gas network, we're talking about a cycle of 1 year. And you can see just how much demand changes. And managing this change in demand, along with changes in supply, that's the key challenge that each network must address. Now, in the case of the travel network, what we're showing here is the traffic on the roads in California throughout a typical day, based on a weekday from Monday to Friday. And it's using data that we've collected from the California government, which tracks vehicle miles traveled across the entire state. And you can see those 2 very characteristic peaks in the morning and the evening, which coincide with travel to and from work. And you can see just how much the usage of the roads varies throughout the day. And of course, the roads have to be designed to allow for and accommodate those peaks that you can see there. Now, the electricity sector, the curve that I've chosen to use here is the well-known California duck curve, which has already been heavily influenced and changed a lot in recent years because of the solar that has been installed in the California state. The data curve also shows quite a lot of volatility throughout the day, with peaks during the middle of the day and the end of the day, where the majority of internet browsing takes place. And then with the gas cycle, this is based on data from Europe. You can see the big peak, which falls in the winter as more and more gas is used for heating. And then a lull in the summer when less and less heating is required. Now, one of the most important ways that networks address these challenges is with storage. And it's interesting to see just how different the amounts of storage are that are installed in all the different networks. Now, in the data network, it turns out that we have literally hundreds of years of storage available to us. In the gas network, where storage generally takes the form of fields, or gas fields, and LNG, we have approximately 70 days of storage. And what I mean by that is that we can store the equivalent of 70 days worth of demand. The perishable goods and travel are in the single-digit number of days, but the electricity sector has just 20 minutes of storage. And this is based on all forms of electricity storage, including pumped hydro in North America, and comparing average daily demand with the total installed capacity of storage. So what this essentially means is that the way you can think about it is that if all of the storage facilities in North America were fully charged to their maximum and all of the generators were turned off, we would have enough storage to power North America for just 20 minutes. And that's a huge difference in comparison to the other networks that we're looking at here. Now, with that in mind, I wanted to just give all of you on the webinar here a chance to contribute. And given just how little storage there is in the electricity sector, I thought it'd be interesting to ask, what do you think the biggest obstacle is to electricity storage being deployed at your organization? Is it a lack of experience, regulatory limitations, a cost of installed systems, lack of financing, or if you're just not involved in deploying energy storage, then please select that option. And I'm going to give you just a couple of moments to think about that and to answer the question before we move on. And then we'll look again at the answers later on in the presentation. Just a reminder at this point as well, if you have any questions that come up throughout the webinar, please just enter them using the Q&A system. And myself and John will be happy to try and answer your questions during the last few minutes of the webinar. So I'm going to move on now, and we'll look at those answers in just a few moments. And this slide tries to summarize just how storage is used and where storage is installed in each of the networks. And the green bubbles represent technologies that are already established, and there is a large number of installations. The blue bubbles represent more emerging technologies where we see growth in the number of installations, and there's sort of newer technologies. And the thing that really jumps out is in the majority of locations, the electricity sector is really just the use of batteries or energy storage in the entire span of the electricity network is really just emerging, and compared to other networks we see relatively little storage close to the individuals or at community level or at city level. Whereas in a network like the data network or the perishable goods, we see very established storage all throughout the network, both large centralized systems and small distributed systems. Which leads us on nicely to the topic of technology. Now, technology is absolutely critical to the transformation of networks and to the evolution of storage. And I think the best way of thinking about this is to imagine one of those pictures that I'm sure all of you have seen before of one of the world's first hard drives. A device that was essentially the size of a large room, costing many, potentially millions of dollars, with the storage capacity that is probably a fraction of what you have on your smartphone in front of you, almost, no doubt. And what's enabled what we have now, which is storage throughout the network in its entirety, I bet that most of you have at least 2, maybe 3, possibly 4 devices with storage embedded in it at your fingertips right now. What's enabled that is this huge evolution in both cost and technology of data storage. But what I think is really interesting is that the value proposition of lithium ion is incredibly similar to the value proposition of solid state storage, which has enabled this. So lithium ion is a highly efficient, smaller, faster reacting technology, just the same as solid state storage was. And they're both on very similar cost trajectories. And it gives rise to the compelling idea that we could see storage embedded throughout all areas of the network in the same way as the data storage network has, thanks to these advancements in technology and cost of storage. But storage alone isn't the answer. There are other things to be considered. And one of the things that we consider to be really important is communications, and in particular smart digital communications. And the best way of illustrating that is to think about the travel network. Now, we consider storage in the travel network to be the seats where people are stored as they're moved through the network. And if you think about the amount of seats that are in use at any given time, we did some analysis of New York, and it turns out that that seats are only typically in use around 25% of the time. So only really 1 in 4 seats on average is being used at any moment. And even at peak times, only half the seats in the network are in use. And this is really mostly because of the fact that the majority of vehicles are cars, and nearly every single car has 3 empty seats in it whilst it is traveling during those peak times in the network. And so there is ample storage in the network, it's just not efficiently occupied. And this is where digital communications come in and are starting to make improvements to this situation. So allowing users to make better use of available seats by using things like ride-hailing or ride-sharing apps. And similar systems are enabling real-time data to be used to make intelligent decisions. So people are starting to monitor traffic levels or how busy a network is and respond to that and make decisions about how they want to travel. And also we see the introduction of pricing mechanisms that take into account how busy the network is. And these are really important in potentially making big improvements to the utilization of the travel network. And that's it for what I wanted to highlight as key findings from the white paper. So really just to summarize before I hand over to John, we see storage and smart digital communications as the key to strengthening networks. And we see the strengthening of those networks as being incredibly important, not just in the electric sector, but in other networks as well. In comparison to other networks, the electric power system has a very alarmingly small amount of storage. And a big thing that's going to enable this transformation and accelerate this transformation is the declining costs and the improved technology of storage systems. And I think another really important thing is that storage can be effectively utilized at a lot of different points in the network. And I think we'll start to see much more storage scattered throughout the system. So the next thing I want to do before I hand to John is just review the answers to the poll question that we asked just a moment ago. So we're going to reveal that now. And it's perhaps not so surprising to see that the cost of installed systems being the major barrier to deployment at most organizations. I'm not so surprised by that. But at the same time, I'm reassured because I do see, as I hinted earlier, a very steep cost trajectory for this technology. And I think that now is probably a really good time to bring John into the conversation. John is the president from AES Energy Storage. He's going to talk to you now about his experience of deploying energy storage into the system and what he takes away from the paper that we've just talked about. But first of all, John, what's your reaction to the answers that we've got here?
Not so surprised, Sam. I think this is a topic that often comes up, and I think one of the challenges as people begin to get engaged with energy storage in the electricity network is it takes a little bit of thinking about cost in a different manner. It really takes looking at what are all of the jobs that storage can perform that we're already purchasing other alternate solutions for. And what we find is when people look at that, they often find that it's actually very cost effective. In all the places that we've done this over the last 10 years, we found storage to be very cost effective as an alternate solution. And in fact, every place we've gone, this has ended up being a cost savings relative to the other things that were done. So this is part of familiarity, and it's also part of what you were indicating is that we are continuing to see very dramatic declines in cost over time. With that, I think we'll move ahead into some of what we saw in interacting with Sam and the team in the course of this study. Part of what we began to see was really what are some of the elements that are going to encompass and make up the new energy network of the future. And some of those underlying trends that we see are a move to electrify everything. We've had this push over time, and in most places in the world you find electricity is the most useful way to power something. It's generally very cost effective. It's the best use of resources. And pretty much every sector of the economy has electrified to a large degree, except for transportation. And today now we're on the cusp of transportation electrifying as well. Within that, another underlying trend around the world is the acceleration towards renewable generation and renewable energy. In some places this is photovoltaic, other places it's wind or hydropower, but we see an increasing move in this direction, in part driven by policy, but increasingly driven by economics. And then a third pillar of this new energy network of the future is the ability to add storage to transform the way the network works and unlock the potential of some of the resources that we've built historically. Up until now, we've had very limited ability to store energy. We've built large pumped hydros in the past to do that, but those were limited to the geographies and the topology of where you could build a pumped hydro. Today, now we have a new technology that's able to go to new places with new characteristics and really begin to transform the network. This new energy network is dealing with some of the historical challenges that we've always had and the goals of our electricity network. First and foremost, the goal of power system providers, utilities, regulators, the expectation of customers is that you have a dependable power system where the lights stay on. And so reliability is always job one. But very closely following that is to do reliability at the least cost possible. And so there's always a pressure to look at new ways to continue to find a reliable power grid at least cost. And then finally, there's a stewardship element to what we do in the sector of trying to find the best mechanisms to beat a reliable grid at least cost with least impact and best stewardship in terms of clean energy. These are kind of the traditional challenges that utilities, power system providers, and others are dealing with. But we also see a couple new trends that have been emerging and are driving the sector to a degree. One is a greater and greater emphasis on the efficient utilization of assets on the grid, and the knowledge that as we build the next power plant, it's being used less than the last ones we built. As we build the next transmission line, it's being used less than the ones we built before, and that contributes to cost. It contributes to a sense of an infrastructure that we might not be getting the full value out of, and there's a desire to tap into that, and policymakers in many places are looking for ways to do that. Similar to the example that Sam was just discussing with technologies that are unlocking the ability to use excess capacity in the transportation network, for example. How do we fill up those seats? How do we fill up our networks? Second, as we do go down this road and a push towards the adoption of greater renewables, we have new capabilities that we have to deal with. We have different forecasting techniques that we need to use for solar and wind. We have to manage the time periods where we can have an abundance of those resources versus the other generating sources that we have on the grid. We have to build out our networks to the places that have the best resources for sun and wind and water. And that goes down this path of renewable integration and really understanding how do we build networks into the future such that we take the best advantage of the renewable sources that we have and that we expect to have in the future. And then finally, a major factor really in many places is the reality that much of our electric power infrastructure is reaching the end of its useful life, it's aging, and our society in many parts of the world is looking forward to substantial reinvestment into this critical network. And as we look forward to that investment on the order of billions and trillions of dollars over the coming decades, what are the decisions that we make on infrastructure that will last 10 and 20 and 30 years into the future? How do we take advantage of the current technologies to make sure that those are prudent investments, that they're flexible investments that are coming into a power system that's in a period of change? And we see rapid change in many places. These are the challenges that exist, and storage comes into the context and really nicely meets a lot of these challenges head on. And I think that's why we're seeing the growth of storage in so many places around the world. First, as we look to a more uncertain future with dynamic sources of generation like PV solar, wind, we need to complement that with a dynamic source of flexibility like storage. Storage systems have the capability of responding very quickly. When they're attached to the grid, they're always in a perpetual standby mode, so they can be instantaneously used to manage any changes in output. Because they don't have the same kinds of permitting challenges, they don't require us to find sources of water or fuel. They have a limited amount of land use, and they can be built at different sizes and scales. We can place these in locations where we just couldn't ordinarily have put the traditional resources. So there's many places there it would be advantageous to have a power source on the electric network where it's just impossible to permit a power plant today, or it's impossible to get access to water. It's impossible to do some other aspect of it. These storage units can be placed into even residential neighborhoods in a very unassuming looking building, a containerized unit, even a small enclosure-based unit, and we have a source of power and flexibility in a place that's most advantageous to the grid, to unlocking and driving higher utilization of our existing investments, and we just couldn't have done that previously. And this flexibility also supports a renewable future. In every case, it amplifies the effect of other policies that are going on and gives us something that's clean, cost-effective, and adds to reliability. As we move ahead into the next slide, I want to make sure also that you understand that the main area of growth that we're seeing is in advanced batteries. Sam referenced lithium-ion battery cells, and today almost all of the large-scale grid projects are being done with lithium-ion battery cells. One of the main reasons for this is an advanced supply chain. These battery cells are made in high volume today, millions and millions of cells. They're produced by high-quality manufacturers. Everyone in that supply chain is rapidly expanding capacity in different parts of the world in order to meet a growing demand and growing volume from electric vehicles, consumer electronics, and in the power sector as well. So we have a robust supply chain that's already well developed. It's well on the way to making battery packs and modules for vehicles and other types of systems. And that R&D, that bulk of manufacturing, has entered into the power sector, and we're able to take advantage of that combined growth and investment to have systems and components that are ready to scale. Those can be put together into small building blocks where we integrate power conversion and software into a small unit that then can be combined in larger and larger arrays to whatever size is most advantageous. We've been doing this from small scale and a couple hundred kilowatts all the way up to several hundred megawatts in scale. And so this storage facilities can take advantage of that existing supply chain and meet even very large-scale jobs on the power system in the replacement of power plants. And this is taking place in many places around the world. So we've talked about storage coming in, we've talked about the benefits and why it's meeting many of our policy challenges and the ability to scale this up. What is happening now is that policymakers, regulators, utility systems, power system operators are recognizing that storage meets many of the current challenges that they have for flexibility, for cost management, for system optimization, and for reliability. And so in many cases we hear about the large projects, and a lot of times we hear quite a lot about California and the way that they've taken a leadership position with their storage targets. But actually when you look at the map, this is just a sampling of the opportunities and the efforts that are going on around the world. You really find energy storage on the grid as something that's happening in all regions of the world. In many cases, it's being incorporated into the fundamental rules of these power systems. So, for example, in the United Kingdom, storage has been written into the rules as applicable for power capacity, and now it's being procured for that. Mexico is going through a major reform of their energy laws and has begun to incorporate energy storage into what's allowed to meet certain service obligations. In other parts of the world, we're seeing incentives to bring storage in, such as in Germany, Italy, and other places. And then in Asia, for example, we see very large systems going into Korea, existing large systems in Japan, systems securing the Philippines, and most recently in Australia, where we're finding some crises on the transmission system and shortages. They're looking for storage as one of the quickest, most applicable solutions to meeting huge reliability challenges that are causing blackouts in that system. So really a whole array of potential and a whole array of procurements and policy aimed at introducing energy storage into our infrastructure.
Thanks for that, John. I'm going to hand straight back to you in a moment to show some real-world deployments of systems that you've done that are meeting these requirements. But first of all, just a reminder to all the audience, if there are any questions at all about the content that you're seeing here, please just enter them onto the Q&A system, and we should have about 15 minutes or so at the end of this to discuss and to answer your questions. And with that, John, I'm just going to hand straight back to you.
Sure, thanks, Sam. And we'll move ahead here into some real-world examples. I think one of the questions that often comes up are, what are the segments of growth? How big could this market be? We're already seeing this emerge, and in the last year, the size of this market approaching about 1 gigawatt and expanding at a 60% rate. That's approaching somewhere in $1 billion of sales and services, depending on how it's counted, and then growing quite rapidly. One of the first sets of services that we see for energy storage, and often the first place it enters new countries, is as an alternative to some of the power generation solutions that we've historically used. This picture here is an example of an energy storage system that we put into the Atacama Desert in the north of Chile in 2009. In this particular case, what we were able to do was use storage as a replacement for a spinning reserve or a contingency reserve on the network. These spinning reserves require power generators to have excess capacity, or in some cases, idle generators to just be turned on, spinning, burning fuel, in order to supply power very quickly in the event that a power generator fails or a transmission line goes down for some kind of accident or problem. Every power system in the world carries some form of spinning reserve as a cost of reliability. In many places in the world, this is still done by oil or diesel-fired generators because of their ability to quickly be fired up or to be ramped up. And this standby capacity is a great example of something that storage can replace. It can take those generators out of service that are really burning fuel for no real purpose. It can do that standby job and can allow all of those generators to be either turned off or minimized in their need for this. And this is a project that's been going on for some time. Another area that storage frequently serves is moving into another form of ancillary services called frequency regulation, and this is another generation alternative. The project that I'm showing here is a combination of energy storage with a 100-megawatt wind farm. And in this particular case, the energy storage was able to serve a job of regulating the ramp rate of that wind farm and helping mitigate the speed at which it changes. It had the capability to do that, as well as providing frequency regulation for balancing the changes in supply and demand on the grid as a paid service. This operates in the mid-Atlantic U.S. market, and the grid operator, the independent market monitor calculated that this system was saving about $20 million a year in reduced cost to the customers, as well as eliminating 62,000 tons of CO2 and other SOx and NOx emissions from the other plants that ordinarily would have provided this service. In this case, what the storage is doing is responding to very quick, minute changes in supply and demand that otherwise would have required the power generators to be turned up and down, taking them away from their best operating set point. That moving the generators around reduces their efficiency. It causes more emissions to be created. It causes more total cost in the system overall. And so this is another great example of where storage typically enters into new markets. And then finally, what we're seeing over the last few years and increasingly is storage moving into even larger systems and being used to truly replace thermal power plants. This picture here is an example of what's currently the world's largest installed grid battery. This is located just north of San Diego in the Escondido area. It's a 30-megawatt battery, 4-hour duration, that can provide peak power to this part of Southern California. What this allows San Diego Gas and Electric to do is provide peak power when they need it for that main part of the day. It also allows them to absorb excess generation if they get to a period in the middle of the day where they have a significant amount of overgeneration from solar, or a period in the evening when they have overgeneration from wind, to take and store that overgeneration and bring it to a more useful period of the day. It also gives them the fast response capabilities that we were talking about in order to serve any changes moment to moment on ramping or flexibility. And this is located at a point on their grid where it was very advantageous to put a new power resource. But it was also a location where it would have been very difficult to build a thermal power plant, a very constrained site without direct access to water or fuel. And so we're able to bring storage into a location that would be ideal to have a power resource, but where we just couldn't have ordinarily done that. So this is an entirely different way to meet a utility's obligation to provide adequate local capacity. And it did it in a cost-effective manner. It was deployed in 6 months, so very rapid time period from contracting to implementation, and is now in service in San Diego. This just gives an indication of what you can do with these advanced systems when you have a mature platform and where you can move very, very quickly based on experience. Now I want to turn to some other alternatives. So those first 3 examples I gave you were examples where we were using storage as an alternative to a generation source. We're also seeing that storage can be in other parts of the network. And if you recall back to the slide that Sam presented with some of those bubbles about showing that storage can be embedded in different layers of the network, we are seeing increasing attention in working with utility partners on embedding storage at the distribution level of the system. And so this is an example where we've had the opportunity to work with Arizona Public Service to embed storage along 2 feeder lines where they're seeing increased use of rooftop solar, and they're looking at storage as an alternative to strengthening that distribution line and making sure that they maintain a reliable service in that area, adequate service, and they also allow those customers to take the best advantage of solar in an abundant renewable resource. This goes into their rate base and is part of the utility investment, and it serves as an alternative to other things they might have done to strengthen that substation or that line. And it's a great example of seeing storage provide a different job from generation, but one in which we continue to strengthen the reliability in a very cost-effective manner. And then here is an example of a transmission alternative. Now, this is a 20-megawatt, 1-hour duration system that was built primarily to meet new requirements on the transmission network for frequency control and maintaining adequate response times at the transmission level. This utility in the Midwest put it in for that, as well as voltage control. There are also some other services where they're looking at the ability of the storage to be incorporated into a black start plan and program, and to potentially take advantage of it that way. So multiple service capabilities in a project that can be put inside a warehouse into a containerized unit and used in a number of different ways as an alternate to other transmission investments they might have made to meet these same requirements. And then finally, a little bit of a glimpse of the future and where we're going. I mentioned renewable integration earlier as one of the drivers. This is an example of a project we're working on together with the Kauai utility, where they are going to be adding a 28 megawatt solar PV system that will have a 20 megawatt energy storage array for a 5-hour duration. And this combination of solar PV with storage in this particular case, especially on a small island, allows them to really take the best advantage of the solar, to introduce it into their system without concerns about reliability and management of the grid. The 5-hour energy storage system will allow them to stretch that solar over broader periods of the day to better match their load and consumption curve, and to really fully utilize the solar in this overall market. And this is a project that will go online next year. So a little bit of a glimpse of where things are going. Over the 10 years that we've been working in energy storage, we've had the benefit of being able to work in a wide variety of environments. I showed you the desert and the mountains. Some of those are by the seaside. Some are in dense areas, urban areas, like the San Diego project, some in a more remote area, some large grid, some small grid. There's a lot of learning that goes on from each of those places, and one of the things that we've learned is that each power system is a little bit different. You need to tune the system to be able to take its full advantage in that particular environment, and that experience of doing that in many different countries and many different markets has been embedded into our storage platform, Advancion, which can be delivered on a small scale or a very large scale. We're working on projects that are from a few megawatts all the way up to 100 megawatts in scale. And we look forward to seeing this continued change as we go forward and applying that experience to many more markets as this continues to grow. And so with that, I'll turn it back to Sam.
Thanks, John. That was really interesting to hear some real-life examples that we can apply to what we've talked about earlier in the webinar. So the final thing I'm going to do before we start to answer some of the great questions that have come in, and just a reminder again about that Q&A tool there where you can add any questions that you want to see answered. I just want to just give you some key takeaways from myself, and also I'll turn it to John to give his takeaway as well. I think it's really compelling and really interesting that all of the networks that we can think of, and in particular the ones that we studied in the white paper, they all experience this same challenge of demand that varies throughout the day or the week or the month or the year, and balancing that with supply that typically varies as well. And looking at how all these different networks resolve that challenge is really very interesting. And the other thing that just jumps out at me from your presentation, John, is this idea that this is available now. It's the cost that gets talked about so often. It really is already at a point where we can make this make a lot of sense. And these systems are already being deployed, and that gives me a great hope for the future, as we'll see this in much greater volumes very, very soon. John, is there anything you'd like to add? Any sort of particular takeaways that you would like to summarize from the presentations today?
Sure, Sam. I think in working with your team, I think one of the things that was interesting to us was to find such a clear implication from other networks, and as a sign to what we think is coming to the electric power system, of the ways in which storage is used as a cost-effective way to meet these peaks and avoid having to overbuild the power system. And now today, as the technologies are making it possible for us to do that in the electric system, we're seeing that promise realized. Everywhere that we've introduced storage, it's been a beneficial cost reduction to that system while improving reliability. So I think that's really an important takeaway, and it mirrors what we see in other networks. It mirrors our 10 years of experience in the electricity grid. I think in terms of being available and now, we continue to work with utilities and system customers around the world to deploy larger and larger systems. So that's clearly here today. And we've seen from when we started working on those early projects and some of the things around like the project in the Atacama and others, about an 80% cost reduction from that time period to today in terms of the installed cost of a system on an energy basis. So very dramatic cost declines already. The more advanced systems are already incorporating and building in expectations of future price declines. They're getting smarter in terms of design and being compact. And so I think the growth that we're seeing in the market over the last few years and approaching a gigawatt of newly contracted systems this past year is really a testament to that fact that we're finding many places in the world where this is already cost effective, and even more as we continue to see costs and experience move forward.
Perfect, John. That's great. So what I'm going to do now is I'm going to start to pick out some of the many questions that we've got here. We've got some really good ones, and we've probably got best part of 10 minutes to talk through some of them. So one of the ones that jumps out here at the top is around talking about cost once again for batteries, and I know that that's something that we've talked about a little bit already. So this attendant is asking, how do we capture the price fall of battery cells? And in particular, what I find interesting is this a risk for developers? Now, just to add, I think we've tracked price reductions of something between 50 and 70% decline over the last 3 years for lithium ion, and depending on which specific technology or application you talk about. And we're predicting between 10 and 20% per year going forward as well for the next few years. But maybe you can comment on that and also give any thoughts on whether these price reductions are a risk for developers or not.
Sure. I mean, as I mentioned, I think our findings in deploying real projects are similar, that we've seen cost reductions over the years and continue to see those coming now. It's not just coming on the battery cell side, it's also coming as, these systems are designed better and starting to see this happen in the balance of plant costs. So, for example, the system that we offer to people is already a 4th generation system, and we're continuing to incorporate new ideas into ways to bring down the cost. I think, like anything that we see, we are going to see progression of this, like we see in solar, we've seen in wind, and we've seen in other things where costs will continue to move. I think the question is, do we have a business case that makes sense today? And then as we move into the future, there will be additional business senses. Many utilities and developers and so on are moving along a portfolio basis. We won't just build one set of projects and stop. I think we're at the very beginning of a whole series of projects, and similar to what we've seen in other spaces is we build those and then we continue to go forward and take advantage of the next project at the next cost basis. In some cases, one thing that's important to build in is the flexibility into these systems to take advantage of future cost reductions as you begin to upgrade, mitigate, or deal with degradation of these power systems and storage systems. And so you want to make sure that you're buying into a storage system that has the capability to allow you to use the best and least cost technology in the future when it comes time to do maintenance and upgrading of those systems. And I do think that's a key consideration in managing risk for developers. Okay,
that's good. I've got another question here which I'd like to get your thoughts on. And it's to do with whether we think the biggest potential is in either grid level or distributed storage. Now, I would add here, based on IHS analysis, this does vary significantly by country. We see very strong markets for behind-the-meter storage in both the residential and commercial sector in some countries, and markets that are much more dominated by large grid-scale systems. At least in the short term, we see very clear trends in the different markets. But interested to hear your thoughts for certain, John. Do you want to offer anything on that?
Sure, Sam. I think you're picking up on a very important point there, which is often the regulatory environment or the policy environment has a big impact on where we see that growth coming. In our view, we've been working primarily at the utility scale and with alternatives to generation and transmission investments, distribution investments, and we see very significant projects there. But what we learn from other networks, I think, is that we will see storage embedded at many different layers of the system. It will find places where it's cost effective to do some things in a more distributed fashion. I think, we'll find places where it's more advantageous to do it in a semi-distributed fashion, kind of what we're doing today. And then probably even some places where even more centralized, larger systems would make sense. So I would expect we'll see a broad span of those things. But we do expect a lot of that growth to come from fairly large-scale systems that can introduce a great deal of benefit very quickly. And so these two will sort of be in parallel with one another. A lot of the places where we've seen the most activity with distributed systems, it's been primarily fed through a subsidy or an incentive program, whereas a lot of the large-scale systems really have been done on a fully commercial basis. So I think that's a question to ask as well.
Okay, yeah, I absolutely agree. We'll keep moving on because we're running short on time, and I want to get as many questions asked as I possibly can. But there's one here that I find interesting and that comes up a lot, and it's to do with the role of government subsidies. So someone's asking, what role should government subsidies and financial assistance play in expanding utility-scale energy storage? It's interesting coming from researching solar as well as energy storage. I see very differing pushes on whether subsidies should exist or not in markets from those two sectors. Maybe because so many people in the solar industry have faced such big challenges on the back of incentive changes. But John, I'd like to hear your thoughts on that.
Sure. Yeah, and we get this question quite often. I think, obviously these kinds of subsidy programs have an ability to accelerate deployments and to move things ahead. I think if they're well designed, they can help push the industry forward and provide a clearer path to scaling up, and I think that's important. We've been working in this space for quite some time now, and if I go back to the beginning of that sort of 2007, 2008 time period, where people were very unfamiliar with the technology, the suppliers were unaccustomed to dealing with the power sector, it was challenging even to get interest and attention to creating a solution. One of the reasons that AES got involved with the development of the Advancion platform and the system was we were seeing benefits from energy storage, but really unable to purchase a system that met the needs of a developer and of a power system operator from anyone. And so we worked really hard with our engineers and with external supply partners as well to create a system that really was suited to the long-term owner-operator of assets. And that's really what has turned into Advancion. When you have those kinds of government subsidies and other financial assistance, they can create a clearer path to that future that helps people move along that curve. I will also say they can also have a chilling effect at times if they're not done well. And so if we look back to the U.S. Recovery Act as an example, there were programs in the U.S. Recovery Act for energy storage. And one of the things that we reflect on now a few years later is it really limited the amount of new commercial activity for a period of a year or two while companies worked to obtain those incentives. And then in some cases, those programs were really done more on a demonstration basis and not a truly commercial basis. And so there were a lot of additional costs that were added, a lot of additional scope and requirements testing that people wanted to do that caused those initial systems to not really be a good example of commercial costs of what you would do on a scaled up basis, what you would do with a very focused program. So my sense is that there's pluses and minuses to these programs. They need to be done well. I think we've seen a lot of good examples in the solar industry of programs that have been done well that have had the effect of scaling up that industry and getting us to a cost basis that's really quite remarkable today, much lower than people imagined because of that scale benefit and providing a path to certainty. If we can provide more paths to certainty for energy storage, we'll continue to see advancements in cost, advancements in the technology. We've built a very large portfolio working with customers that has basically not been fed by subsidies or government support in any way. And so, speaking purely as a supplier of systems to people as well as someone that's done commercial development of storage, there are plenty of opportunities for storage today that don't require those subsidies. That said, if they do come, they will have the effect, if they're well designed, of accelerating the industry and continuing to move us down a very positive path.
Yeah, I think that's a really good point, and I completely agree for sure. I want to try and get two more questions in, and we're running short on time. There's several questions here around around the lifetime of systems. That's certainly something you've got more first-hand experience of than myself. Can you maybe just talk a little bit, John, about expected lifetime of AES systems?
Sure. Yeah, and I would say this is probably an area that is highly misunderstood in the industry and is also very opaque. It's very difficult in a lot of cases to get to the end of this. As I said, we started out as somebody looking to deploy energy storage that we would own and operate. We've transitioned into being somebody that supplies these systems now to other utilities and power system operators, developers, based on our experience. But as an owner-operator, kind of that being a little bit of our DNA, we really looked at how do these compare to other power assets that we own as a long-time life cycle asset, and how do we really optimize to make sure that we're taking advantage of being able to get that investment recovered over a fairly long life. We are typically building these systems to be 15 to 20-year systems or longer in some cases. But that takes some thinking about the architecture of the system. One of the key things that really drove the way we've designed the Advancion 4 platform is looking at maintenance and replacement costs, looking at how you want to manage a system over a longer period of time to take advantage of being able to insert new types of better cost basis batteries in the future. How difficult is it to maintain certain types of systems? Our earlier generations of systems that we installed, we ran into challenges with that kind of maintenance program and having stranded energy in some places in these systems, efficiency challenges in performance, and really cumbersome mechanisms for upgrading. And so I would just say to anybody that's looking at this area and particularly looking at short duration systems, the challenges will come in year 3 and 4 and 5 and 6 as you start to see wear on these systems, and you have to deal with managing them and upgrading them or maintaining them over time. You need to have a really well thought through plan for that, and it needs to interact with the way the supplier has built the system in order for you to be able to take advantage of the advances that are going to come in that same period. So I think those are some key considerations. Like I said, most of the customers we're talking to, we're looking at least a 15-year life but it varies quite a lot. Some people are looking at 7 to 10 years. Other people are looking out longer at 20 or 25 years. The systems can be designed to do each of those things. And it's really the consideration of how you build in the flexibility to take advantage of the advances in technology over that time period. Really kind of future-proofing the system is important.
Yeah, absolutely. I feel like we could probably talk about this topic alone for a whole hour on a webinar. Maybe that's a job for another day. So I've got one more question that I want to just try and squeeze in here. I know we're running short on time, but let's see if we can just quickly address it. So there's one here about where we think the biggest development opportunities are abroad, and I'm going to assume that means outside of the US. It says, are they in the developing world? And is it with spinning reserves and generating ancillary services? And what other services do you think are more important in the next 5 to 10 years?
That's a great question.
Yeah, I mean, in my thoughts, one of the things that we've been looking at a lot recently is you can clearly see trends towards batteries being used in longer duration applications. 1 or 2 years ago, most battery systems were looking at almost exclusively frequency regulation. Things like what we see in Korea, the EFR in the UK, and in PJM. But more and more we're seeing evidence that batteries are now at a cost point where it makes sense for longer sort of multiple hour systems doing things like capacity as well. So do you agree, John? Have you got any thoughts, anything you'd like to add?
Yeah, I think we see that same general trend that you're pointing out, Sam, of systems moving to longer and longer duration. I think very often we see the short duration systems being more of an entry point for the initial services. Many markets will introduce storage or allow storage to participate in the regulatory scheme at these short duration ancillary services as kind of an initial familiarity, the ability to bring them in and begin to integrate, working with them. There's often a number of challenges as you first bring storage into a new power system, just in that it's unfamiliar to whoever's managing that system. It needs to be integrated into the generation control system or the demand management system or the operating systems. It may need to have items modified in even how something offers a bid or offers capacity. One of the things that we found in the past was, we would bring storage, and because storage has the capability to both supply energy, in some cases it's looked at as a generator, in other cases it's looked at as a controllable load because it can basically absorb energy or act like a curtailed load. And so in many cases, we were asked to register twice. Like each megawatt ended up becoming 2 megawatts in the eyes of the system operator. And this goes a little bit to how storage is treated on the regulatory front. I mean, we've generally said storage should be treated in accordance with the job that it's providing. And I think most systems are going along pragmatically with that view. And that's kind of the right way to think about it. It allows us to take advantage of the existing regulatory frameworks and then adapting them at usually at the operating level to account for some of these performance characteristics. So longer duration is where things are going as people get familiar, really seeing this as a true alternative to peaking power plants, seeing it as a true alternative to some of the transmission and distribution upgrade work. We're working with a number of customers where they're looking to defer very large-scale transmission upgrades, and actually in some cases not even looking to defer them just so much as those large-scale projects can often take 5 to 8 to 10 years where the problem has emerged more urgently. And so adding storage can be a mitigation to a problem until somebody could resolve it or until it makes sense to resolve it in a different way. It may be that a transmission line or a system gets overloaded a certain part of the year, but not the full time of the year. And so if you could delay that for some period, it's a better use of the overall infrastructure. So those large-scale projects, those require longer duration, an hour to multi-hour systems. We're doing more 2 and 3 and 4 hour duration systems, and we really think that will be the lion's share over time. those longer duration systems have the capability to do those short duration jobs as well. So over time, they'll have an impact in that way as well. And then I would say probably the third thing we see is different combinations of resources. So we've done some projects already where we've combined a thermal power plant and a storage facility to get a better total capability. We've done combinations of renewables with storage on both wind and PV. And so those are other interesting opportunities for storage where, you take advantage of the types of controls that we've built into Advancion to bring storage and have it operate in conjunction with some other power asset to make the sum of the parts greater than one. And so we're doing a lot of work in that area and see that kind of as another growth area. And again, that's typically going to be in, at least, medium-term duration to longer duration systems here. So.
Okay, thanks, John. Really appreciate that comprehensive answer. We are really out of time now, so what I'm going to do is I'm going to hand back to Alan just to quickly wrap up. Just to quickly add, I've got a message here that if any of your questions that we've not been able to answer, and there are quite a lot, please feel free to get in touch. You can do that directly or via the AES Energy Storage website, the contact form. You can reach people from AES easily there. Very happy to hear from all of you online today, and I've really enjoyed presenting with you, John, and to everyone here in the audience. Back to you, Alan.
Thank you, Sam. I want to thank everyone as well for your participation on our webinar and for submitting all of those questions and comments. We have received a large number of questions, and our panel will follow up with you via email after the webinar. I also want to thank Sam for leading our discussion today, as well as John from AES Energy Storage for this very informative and dynamic presentation. So thank you, gentlemen. An archived version of this webinar will be available shortly, so feel free to come back and view this session again or even share it with your colleagues. And you're also going to see a short survey pop up at the conclusion of the webinar. Please take a few moments to fill that out. And make sure you follow us on Twitter for information on future IHS Markit Technology Group webinars. So again, thank you for joining us, and have a great rest of your day.